Hi, everyone. In this presentation, me and Beinan will talk about our journey of spinning up Presto at Uber with Alluxio caching. So to first give an overview of our environment, we have about 20 clusters with a total of more than 7,000 nodes. And we run 10K weekly, we have 10K weekly active users who run over 1 million queries every day. And the queries need to access more than 70 petabytes of data on a daily basis. The scale is massive. So in order to support this scale, one of the key optimizations we adopted is local disk caching with Alluxio. There have been resources from Meta about their journey of adopting Alluxio caching, which is very inspiring work to us, and I highly recommend to everyone interested in this topic. Similar to Meta's setup, we run Alluxio as a library on each Presto worker node, and it leverages the worker node's local disk as data caching to accelerate data fetching from HDFS, essentially. And we primarily support the scheduled queries, because their repetitive nature fits well with caching. And also, currently we run caching over 6 clusters with a total of about 20 to 100 nodes. In this presentation, we'll be mainly focusing on the challenges that we encounter that are specifically to Uber's environment and use cases. I'll go through each of them. To start with, the first challenge we encountered was the real-time partition updates. So at Uber, a lot of queries are upsert queries into hoodie tables. What that means is that the table and the partitions can be mutating over time. And this is to the problem that, say, in HDFS or Hive, the table partitions may have already been updated. But the cached copy in Presto is still the old version. In this case, if a user updates the table and then try to read from Presto, then the users may get if the read is served from caching, then the users may get outdated stale data. So to address this issue, our solution is to have a way to distinguish partitions from different points of time. Or essentially different versions. Specifically, we add the latest modification time to the cache key. So instead of using just the path, which is the current cache key in Presto, we append the latest modification time to the partition path and use this as a cache key. With this, every time when the partition gets updated, will be written into the cache using a different cache key. And also the reads into the cache will also use the new key, which has the latest timestamp. This way, we can guarantee that it is always the latest partition read from cache. The old partition will stay in cache, but they will eventually be removed from cache thanks to cache eviction, because no one is using that. So this solves the problem of real-time partition for us. Another challenge I want to talk about is about the cluster node change. So when using caching, we need to make sure a partition is tied to a specific set of nodes, such that the repeated reads can hit the node which has a cache data. This is currently achieved by using a modular hash function by default. However, nodes can go up and down due to operational activities. When that happens, the default modular function can lead to selecting a wrong node. A simple example would be, say we have 3 nodes and a partition of key equals 4. Then the first time it will be, when there are 3 nodes, the modular will tell you, like, will try to locate the partition on node number 1. But like if the node goes down and there are only 2 nodes now, then the same key 4 will be will route to node number 0, which doesn't have the cache copy, and the node will need to fetch data again. So that's basically inefficient in terms of caching. So the basic takeaway here is that even one node change can cause cache performance regression cluster-wide. And our solution to this is instead of using the default modular hash function, we switch to using consistent hashing implementation. Essentially, all the nodes and partitions can be placed on a virtual ring, and their relative ordering or positions never change. So when the coordinator looks up for a node to process the partition, it traverses the ring and finds the next closest node on the ring to process this partition. And with this change, we can guarantee that the same partition can consistently hit the same worker nodes, regardless of other worker nodes change. And this basically solved the problem for us. So the last challenge I want to talk about is that the volume of data that we need to access at Uber is way too large compared to the disk space we have available for caching. If you remember, we're talking about accessing over 70 petabytes of data daily versus only about 120 terabytes of disk space per cluster. So if we just blindly throw all the data into the cache read path, then it can cause performance issues because the cache hit rate will be low and the cache eviction will be frequent. And as a result, the overall latency will also increase. So, and our way to tackle this is basically to have this notion that we call cache filtering. The idea is that to have to only selectively cache a subset of all the data. So every worker node will have a static config file that basically tells which table should be cached and how many partitions to keep in cache at maximum. So only the tables in this config file will be cached, given it hasn't met its partition limit. We identified a list of tables that are most frequently accessed and put them into this filter. So using the cache filter helped us to increase the cache hit rate by a lot, from 65% to over 90%. And latency was also much lower. A catch here, obviously, is that the table needs to be added to this list manually. And this could require domain knowledge or some traffic pattern analysis. This is a trade-off that we made. And it is in our roadmap to introduce automated table detection and filter update. And then I'll hand over to Beinan to talk about more about our next steps and what else is coming in our roadmap. Okay.
Thank you, Chen. Yeah, I'm Beinan from Alluxio. I'm also working for Presto DB community as a Presto committer. Today, I will share some new features in the current and the coming release of Alluxio. For local cache, we will support the two new cache storage as in-memory and the RocksDB. The RocksDB ones can help you running local cache while on the mechanical disk. Also, we will support multi-disk and multi-directory. If you have multiple SSDs, you can enjoy this feature to expand your cache storage. We also do some optimization on the tiny read. If you just read the 1 byte or several bytes from a packet file, this will definitely help. We also enabled a pen-to-file feature, which will support the write features for the local cache. Next page. Here is some features still under experiment. One is, as Chen presented, we will support the persistent metadata to prevent the caching the outdated data in the local cache. This one will also help our local cache to recover after the server restart. We also implement a cuckoo filter-based shadow cache. This one will help you to do the estimation on your working site. The last one is the table level metrics. We will provide the table level metrics in Presto DB. As this picture showed, you can see the hit rate of each table. Next page. In the future, we will support the SSD endurance. We will put some RAM limiting on the right part, which can make our SSDs to last longer. Also, there's still some performance tuning work to improve the performance of our local cache. For the shadow cache, we will introduce something called adaptive caching replacement rather than the RRU or RRFU. I think the adaptive caching will help to improve the cache hit rate further. Also, we will provide table level working set estimation and the partition level probability estimation. I think that this tool will help the cache filter performs better and help also improve the hit rate. Yeah, I think that's everything we want to present today. If you have any questions, you feel free to ping us via Slack. Yes, thank you.
Thank you.